we mentioned that, okay, most of the value you pass into the function are passed by value. That means you're making a copy of that value, right? We have talked about it. Some exception, including the array we have talked about so far, which is passed by reference. In that case, you can essentially say that's passing the exact same array into the function, right? Because we're passing the address of it. This is called by passing by reference, right? The reference here means the address. So this is done by design, okay? This is not any limitation, rather it's a choice, because often we're saving a lot of information in an array. Let's say we have an array size of 1,000. That means 1,000 numbers in this array, right? At least. We don't want to make a copy of those size of 1,000 array every time we call a function. So this is the way who designed the C to decide this is a more efficient way to handle this large amount of data without the overhead of copying back and forth. Next week, we're going to talk about the pointer, which, yeah, you may already learn from Java, but again, that's a way to call function by reference, okay, in addition to the array we have looked at here. Structure also passed by reference, but again, we haven't talked about it yet. So here is a scenario. So if we're passing one character, if we're passing one character, as we already learned, the character are variable character is saved as an integer internally. So passing a one character is the same as passing an integer, and which is passed by value, means you make a copy of it. However, if we're passing a string, because in C, string is saved in array, so they're passed by reference, right? So this is different. So comparing passing one character versus a bunch of characters as a string, the scenario are different, right? First is copy, second is just sending the address of your array. In Java and Python, not Python, but in Java, the string are defined as objects, so they are actually passed by value, not by reference, just to tell you the difference here. Okay. The other concept here is called portable function, which means is if we could create a function that will accept a variable number of arguments. So sometimes it takes three arguments, sometimes it takes 5 or 7 or 9. It's like it could change every time you call it. One example would be printf, right? When you do the printf, after your first statement, you could have as many comma after as you want afterwards, right? This is possible because in C, you will, in your first argument, you will provide enough information to tell the program how many more arguments they should expect from there, right? Remember the percentage sign you have to append on after. The other way, if we want to append a no amount of argument, is that if you knowing the type of the argument already, all right? So if every argument will be integer, for example, that means you can have a variable number of arguments. So only those two cases works. That means in C, this is not a truly portable function. It only works under those two scenarios. But in other language like Java and Python, you could potentially create a program that accept a variable argument without those two constraints, those two conditions, or just some concepts. Again, we'll review this external variable. Okay, external variable we have talked about before. Essentially, external variable are defined outside the function. In that sense, you could also believe that functions themselves are external, right? Because they're not defining within another function. So that means those function and external variables are by default called global, right? Function, and any other function can call it. External variable are often like not recommended. Well, last time I mentioned, right? Because you might lost track where the variable was defined. Let's say you have two functions, they're accidentally modify the same value, and you didn't know the order of the operation, it will create a mess. However, if you do know, you do have the intention to use them across two functions, especially there's no connection between those two functions by itself. Or I will explain that with an example later. But essentially, that means if you have to, in your main function, you have create a variable and send this variable to function 1, do a bunch of process, copy back, then send the variable to function 2, do another bunch of analysis, come back. It's quite tedious, do a multiple copy, because every time you call a function, you will need to create a copy of this, those variables, especially when those variables are big, right? So in this case, we could use external variables in this case. Again, we will take a look of them. Take a look of some example later. But essentially, if you know there are two functions share data, but they're not calling each other, those are often the most usable cases. All right. Other than that, the other reason would be you wanted to initialize some variable before you actually before you actually use them in your function. So because for the external variable, it was able to initialize way at the beginning, so they will give you control of when the initialization works. Okay, so this is the example I mentioned. It might be a little bit confusing in this class. So we're going to make a more usable calculator now. The last example we saw only do the calculation or the adding operation. This time we want to do add, minus, multiply, divide, and equal. Equal is basically just end of the operation to print answer. However, the typical calculator, let's say the Windows can include the calculator could allow you to do operation like in this order, right? Within brackets, 1 minus 2 times 3, 4 plus 5 equal, right? You can do this way. However, in our special calculator, we use a different style. So it's using, because we're using a stack to record all our numbers. So we'll have two number comes in first, then we will have this operate. So we stack, push number 1 and 2 into our stack, and then we do the minus operation between those two numbers. And then we'll push another two number, and we do another operation, and then we do a multiple operation to the top two number in our stack again, right? Well, not if, because you should already know about the stack, so you can hopefully understand this concept here. So this is in a little bit different style, right? It's called reverse polish notation. All right, so how this program should work? We will keep reading. Either it's an operator or operand, right? Until we reach the end. If it's a number, right, we will just push it into our stack. If it's an operand, then we will get our operands from the top of our stack first, then we do the operation, and then we'll push the result back to the stack. Yeah, until we reach the operand which is equal, then we print the last number in our stack, right? So this is how the thing works. And now you can realize that this stack we're just referring to better to be external variable, right? Because that makes things very easy to manage. We don't have to pass this stack back and forth between push and pull, pop, other things, right? So in the mains function, okay, our calculator is basically just keep reading the information. By the way, here we're using a special function called getObs to read the inputs. We will talk about this function later on Thursday, but just assume this will read, the numbers in. Either it's 1 digit or more. It will read everything in until it's reaching to the other type. Say if you have operation 1, 2, 3 space 4, 5, 6, so you will read 1, 2, 3 altogether to your type string. And then, oh sorry, not type string. It's reading into the S string here. The type will tells you if it's a number or it's other symbols, right? So don't worry about this function. We'll talk about that on Thursday. But assume that will read out one of the input, right? So your input will be something like here, like 1 space 2 space minus space, so on and so forth. So every time you run this operation, it will give you one of those entries. Okay. So once you read it, if it's a number, you just push it into your stack, right? You will convert into this is a string. Right now you're converting into a floating point and you push it into your stack. And if it's a plus sign, that means you're going to pop out 2 numbers from your stack and then add them up together and push them back to the stack. And this is how you do it. The same to the multiply, the same idea. But here, if it's a minus operation, you can see there's actually done in 2 lines rather than 1 line. It's not pop minus pop, then getting back to the push. Do you know why this is not the case? Yeah. So if we're adding 2 numbers together, our operations look like this. So we pop, right? That gives us the top 2 number in our stack, and then we add them up and we push them back, right? Push them back to the stack. Yeah, you're in line with what I'm trying to say. So imagine those 2 pop operation. Actually, it's not necessary you always read the right one or always read the left one. Depends on the machine you're running on. It might decide by itself, the compiler will decide by itself, either it will execute this first pop first, or sometimes it will execute the second pop first. And because we're using one stack to record a number, right, we are very specifically, we want to minus, well, we get the first number in the stack and we minus it by the second number, right? So if we do the opposite way, you get the reversed answers. Does that make sense?
Sir, I got a question.
Yeah.
This push pop structure functions, are they part of the C language or you have to make them separately?
We are going to make them.
Oh, okay, okay.
Yeah, thank you for your question. Sorry.
Again, because I didn't understand if the compiler is deciding on this one, but like if I want to plus 2 and 4,
Yeah.
or like minus 2 and 4,
Yeah.
it would rotate it, then the answers would be different.
Yeah.
In minus, it would affect like multiplication or
Yeah, multiplication and plus will not affect, right?
Yeah.
That will not affect. That's why we're using this simpler form, because we don't care which one will happen first. Yeah, but if it's a minus, it matters, right? So we specifically say the first one will be our second part of our minus sign, and then the second in our list will be the first part of our operation. We specify the order of it. Yeah. Okay. So the same applies to this divider sign, except we also handling the case that if it may be a 0. In this case, if it's a 0, we just say, oh, it's not good. We're not going to do it, right? Just break it. Equal sign, essentially, we just show the result. We just print out the result. Note here, we're using pop and push. Well, using the pop alone, you can already get the result, but that also means you remove this result from your stack. To keep it in the stack, you will have to push it back at your stack. So that's why it's push and pop at the same line. We have a special function called clear, just to clear the stack. We'll look at later. Then we'll have to handle the case that it's too big, if the number is too big, or the command is not found as a default. Right? So it's always a good idea to have a default in your switch, just in case something you didn't expect happens. All right, so let's look at the push function here. By the way, this way of defining a function is a little bit old-fashioned. I copied it over from our textbook. That's why you can see this. This is from the 80s. Nowadays, we have this double F inside this bracket, right? Just bearing in mind, there are two different styles, but we will prefer the modern style I typically use. Yeah. But otherwise, the push function itself essentially just compare if the value is received, right? The SP is the pointer of our stack. So as long as we still have room in our stack, and we'll just adding our F value into our stack. That's it. So the val is our stack, and SP is the pointer, okay, pointing at the top of our stack. So by adding a value inside of it, we also want to increase our pointer up, so it will always pointing at the top of our stack. Then it will just have some error handling. If it's exceeding the size of our stack, it will show you the error and clean the stack. Here is the function for the pop. Pop is similar to say, okay, if our pointer is not pointing at the end of the stack, right, then we will just return the value of that position, and then we move the pointer downwards, right, decrement the pointer downwards by 1. And then otherwise, if it was already reaching the end of the stack, we'll say our stack is empty and clean the error. Right, here is this clean stack function is. All right, please keep quiet, possible. Essentially, it just move the pointer to the end of the stack. That's it. That's essentially how you clear the stack. Right. This is a way more efficient way than you remove every single value from the stack. Right. Just move the pointer. note here, like there's no type in front of the function. So by default, it's integer in this case. Well, although it's not return anything anyway, but yeah. Okay, yeah, hopefully you can remember what those pop and push look like. Basically, adding a value to the stack and move your pointer, right? Or removing from the stack. Okay. Now let's look at our last exercise today. So our goal here is to adding 2 more commands in our calculator. One is modulus. The other is erase. Okay, the modulus is obviously doing the modulus operation. And erase is just remove top entry from our stack. Okay, that's it. So you can imagine the modulus is very, very similar to the division, right? And the erase is similar to something we just expand as well. So it should be quite straightforward. Here are some examples. If it's 5 space 3 space percentage sign, you will get 2, right? Because that's the remaining of it. And if it's E value here, so let's say our stack was having 5 and 2 at the beginning, then we add them up and become 7, and then we push another 9. So in our stack, it is 7 and 9. Erase the top one, so it will give us 7 in that case. So that would be the expected outcome. So do some